abstract data type last time known as a dictionary, which is just a set of key value pairs. What's wonderful about Python, unlike pset 5 and C, is that you actually get a data type called dict, for short for dictionary, which gives you exactly that, key value pairs, but you don't have to implement any of the darn logic of problem set 5. It still gives you, in effect, something that looks a little something like this in memory, key value, key value, key value, but you don't have to worry about the array, you don't have to worry about the chains of linked lists, you don't have to worry about the hash function even. Python takes care of all of that for you. Now, this will be a bit of a mouthful to set up, but let me go ahead and do this. Back in VS Code, I'm going to go ahead and create another version of phonebook.py here by first creating a dictionary of people instead of just a list. Because up until now, we've had no phone numbers involved. I do actually want to have a bunch of names and phone numbers. And the way I'm going to do this is as follows. At the top of this file, I'm going to go ahead and create a list called people. I'm going to create a list called people. And a list, of course, uses square brackets. But every person now, I want to have some keys and values, like a name and a number. So how can I do this? Well, I'm going to make some room for this. This is not incorrect. I'm moving this close square bracket to a new line because I want every element of this list to be very clearly a dictionary, a set of key value pairs. And you couldn't do this in C, but you can do this in Python. In Python, you can use curly braces to represent a dictionary of key value pairs. How do you define the keys? You put the first key in quotes, you then put a colon, and then you specify the value for that key. If you want another one, you do a comma, you then do quotes, and you do another key, colon, and then its value. And if I think back to week 3 rather, we used +1, 6, 7, 495, 1000 for Yulia's number then. And that's it. It's a little cryptic because it's all on just one line, but it's like having 2 rows in this visualization here. Name, Yulia, number, +1, 617, 495, 1000 in their chart. So if I want a second one of these, I'm going to put a comma at the end of Yulia's dictionary. I'm going to put myself on the second line. So open curly brace, quote unquote, name, colon, and then David in quotes. Then comma, number, close quote, colon, +1, 617, 495, 1000 as well. And then lastly, a second comma, so that we'll put John Harvard in here. So his name is quote unquote John. His number is +1 949 468 2750. And now we have a list of 3 dictionaries. Each of those dictionaries has 2 keys and 2 values respectively. Syntactically, this is a pain in the neck, and we would probably just store all of this information in a CSV or a database or something like that. But for now, I typed it all up manually so we have a working example. Now, let's actually search this list of dictionaries for the people I want. Let's set a variable called name equal to the return value of input, prompting as before the name we care about. Then let's do this. For each person in that list of people, let's check if the current person's name equals the name the user typed in, then get their number by looking at that person's number field, and then go ahead and print out with an F string something like found, and then I'll just print out that number in curly braces. And then I will break out of all this, or as before, else let's go ahead and print out not found. So this is a mouthful, but let's consider what's happening here. First, on line 8, I'm iterating over every person in people. What is people? It is a list of 3 dictionaries. So on the first iteration, person is this person. Second iteration, this person. Third iteration, this person. And Python just takes care of that for me, like we've seen with our for loops already. If that person's name field has this name, then I found the person I'm looking for. Get their number, stored in a variable called number, if only so that I can print it out with this F string. Else, go ahead and print out not found if I never actually break out having found someone. Notice then that just like in C, when we use square brackets to index into an array, in Python you can index into a dictionary by literally using the same square bracket notation. So instead of saying bracket 0, bracket 1, bracket 2, you can say bracket name, quote unquote, and that will look up the value for that key. So again, it's like going into this chart that we see here visually, looking for name in the left column, finding that person's name, looking for the number value in the left column and looking for its corresponding value at right. It's all sort of happening for us automatically. Now, it turns out we can do this more simply if we instead restructure our variable called people. So let me go ahead and do this. Let me go ahead and delete all of the code we just wrote, including that for loop, and let me redefine people as follows. And I'm going to leave the first version up there so we can see before and after. Let's redefine this variable as equaling people, but instead of people being a list of dictionaries, let's just make people one big dictionary whereby it has two columns, key and value, but where the key this time is going to be the person's name and the value is going to be their number. This is super useful in this case because I only have keys and values, names and numbers. This will not work if I also want to keep track of their email address, their student ID, and multiple values as well. In this case, it suffices to keep track of names and numbers, if only so that I can remove some of this redundancy of saying name, 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 number, number, number. Let's do it as follows. So people equals, open curly brace, close curly brace, and let's add a key of Yulia, whose number is exactly this one here. I'll copy paste to save time. Let's add another key whose name is David, whose value happens to be the same number. Let's add a third key whose value is John, and set that equal to this number, so that now at the end of these lines of code, we have Julia as a key, David as a key, John as a key, and their numbers respectively as values, effectively implementing this chart for everyone instead of one of these charts for each person. So if I go back to VS Code, let's get rid of the old, more verbose version. Let's go back here, and instead of using any kind of loop now, because there's no list involved, let's just do this. Prompt the user using the input function for the name whose number they want. Then let's just say, if the name you're looking for is in that people dictionary, well, great. Go ahead and print out a format string that says that person's number is whatever is in the people dictionary at that name's location. Else, let's go ahead and print out, for instance, not found. So the only weird thing here, I dare say, is this. If name and people works just like searching a list, but you can search a dictionary by key. And if you find a key like Yulia or David or John, it's going to allow you to use people as well, index into that chart at the name location with the appropriate row, and that's going to give us implicitly that person's number. Because even though we don't mention name, we don't mention number, this is what a dictionary is, a collection of key value pairs. And the key can be any string you want, and the value can be anything you want as well. So that was a lot. But you'll see then in the real world, these dictionaries, or really these hash tables underneath the hood, are so useful because you can constantly associate one thing with another. Questions on any of this to date? OK, a few final examples. I feel like it's a tough crowd because we're teaching an entire language in a week. But we're almost at the finish line here. And then everything else is going to be icing on the cake. How do we go about implementing now in Python some of the features we eventually introduced in C? Namely things like command line arguments, which we've not used thus far in Python. I've gotten all of my input using getInt, getString, and Python's own input function. But I've never typed any words after the prompt when running Python and the name of a file. Well, how can I go about doing this in Python? Well, let me open up my terminal window here. Let's open up a program like greet.py, reminiscent of week 2's greet.c program. And let's do this. From a feature of Python called sys, import argv, which is very different from C, but the same idea at the end of the day. If the length of that argv variable happens to equal 2, let's go ahead and print out a format string that says hello, comma, argv bracket 1, close quote. Else, go ahead and print out the default from week 2, which was just hello, comma, world. All right, what has just happened? Well, first let's run it and try to infer. So Python of greet.py, enter. I didn't write any other words after the prompt, so I literally see the default hello, comma, world. What if, though, I write Python of greet.py and then David? Well, what's going to happen here is Python, via this sys library, is going to automatically put every word I typed at the prompt after the name Python into a list called argv by definition. I can then check how many words are in argv, and if it's 2, that means that the human typed in not only the name of the file to execute, but also something after that as well. So if I now run this by hitting enter, now I see hello, comma, David, because there's 2 things in that list, greet.py and David. There's no mention of Python because that's the interpreter, and without the interpreter, none of this would work anyway. You get the name of the file and the word you typed after that. It's not going to work, though, just like in week 2, if I do David Malin, because now argv's length will be 3 instead of 2, so I'm again going to get the default. But this is to say there is still argv. There's no argc because you can just use the length function, len, to find out what the length of argv now is. What more can we now do? Well, let me go ahead and propose that we introduce, how about exit statuses as well, whereby, recall that in C we had the ability to actually exit with some value, like 0 on success or 1 or anything else upon failure. Turns out that that feature is also tucked away inside of this sys library. Let me go ahead and create another program called, say, exit.py, just to demonstrate this one. Let me go ahead and import sys so as to have access not only to argv, but also a function in there called exit, which just worked in C. But in Python, we'll see that we want to use the version tucked away in sys. Let's do something like this. After importing sys, let's check if the length of argv does not equal 2 things. Let's go ahead and yell at the user, quote unquote, missing command line argument. And we didn't spend long on this in C, but we did something like this a few weeks back. And then let's go ahead and call exit of 1. Otherwise, if we get down here, let's go ahead and say, as always, a format string of hello, comma, sys.argv bracket 1, just as before, so as to greet the user. And then we'll say exit 0. But I do want to use argv that's inside of sys, and I want to use exit that's inside of sys, because according to the documentation, that's where these symbols are. So I can now do sys.argv, and I can do sys.exit and sys.exit, which just makes super clear that those 2 symbols, argv and exit, are inside of that sys library. And we did this earlier when I played around with the Cs50 library, either importing specific things or the whole library itself. The idea here is ultimately the same. So let me run Python of exit.py with no command line argument. So enter, and I indeed get an error message. And this is probably not something you've needed to run since I last did it, but if you do $? after echo, you can quickly see what was the actual secret exit status. If I run this again with my actual name, David, enter, I actually get greeted. And if I do that $? again after echo, I see now the secret exit status. So again, not something we've used often, but by convention, we can still do in Python what we've been doing in C, namely signaling that something was successful or a failure. Let's do one last set of examples that are reminiscent of past ones, and we'll conclude with 2 new ones altogether. Recall that we've had this phone book that previously took input just from a hard-coded list of dictionaries or one dictionary. Let's actually reintroduce the idea of CSV files, comma-separated values, whereby we can actually save this information to disk so that we can add and add and add, and heck, even remove names and numbers eventually. In Python, one of the things that's wonderful is that you have built-in support for CSV files. You don't have to worry about the commas, the quotes, or anything like that. As follows. So let me run code of phonebook.py to reopen that same file from earlier. But let's delete everything therein. And let me now do this. Let me import Python's own CSV library, which is, again, comma separated values. And we used this briefly for my last phone book a few weeks back. Let's now open a file using the open function that comes with Python, it turns out, opening a file called phonebook.csv in append mode. So we can add to it, as we've done in the past, line by line. Let me then go ahead and ask the user for a name using input. And then let's ask the user for a number using input. And then let's actually put that name and number into the file. How can I do this in Python? And again, the goal here is not to absorb exactly how to do this in Python. It's certainly reasonable to look this up, but just to show you how relatively easy it is. I'm going to create a variable called writer, though I could call it anything I want. And I'm going to set that equal to the CSV library's writer function that just comes with it. And I'm going to pass to it the name of that file. This is a feature that says open this file and be ready to write to it hereafter. How do I do that? I can do writer.writeRow, and I can pass in a list of the things I want to write to it. So I can say name, comma, number in square brackets. So that prints out a new line to the file. And then at the very end of this, let's do file.close to close the whole thing. Now let's see what just happened. Let me go ahead and open up phonebook.csv, enter, which is empty initially because nothing's in there. Let me show it at write continually. Let me now run python of phonebook.py, enter, and let's do Yulia's name. Yulia, enter, and then her number, +1 617 495 1000. And watch what happens at top right when I hit enter, because that row will be written. All right, she's now in the file. Let me run it once more with my name and +1 617 495 1000, enter. And now I am written to that file. And if I want to do this for John Harvard or anyone else, I can do that then as well. So what's nice is that notice that the right row function is actually outputting the commas for me. And if there were weird characters or commas, it would actually escape them by using quotes as well. As with Python in general, I can tighten this up further. In fact, it turns out that in Python, you don't need to be so pedantic as to open the file, then do some stuff, then close the file. There's this weird other preposition in Python, namely with, that allows you to do multiple things at once. So let me do this. Let me get rid of the close line, and let me instead do this. With open as file, colon, and then let me indent all of this here. That now is going to have the effect of actually doing all of that, but automatically closing the file for me. So I don't run the risk of forgetting, maybe leaking some memory somehow, and so forth. And there's one final flourish I can do here too. Right now I'm using this basic writer function, which essentially just writes a list, writes a list, writes a list. There's one other way where I can write dictionary after dictionary after dictionary, which is handy, especially if I don't just have names and numbers, but maybe email addresses and student ID numbers and other types of values as well. And I can do it as follows. Let me go ahead and let me say, oops, and actually, just to be clear, this code can be outside of that with, because I can ask for this once without the file actually being open yet. So let's change just these two lines here. I can create a writer, but this time use a dictionary writer, which allows me, again, to write dictionaries, key value pairs, instead of just lists of values, lists. I can say use this file for my dictionaries. Let's use field names of quote unquote name, comma, number, and then let's go ahead after that and do writer.writeRow, and I can now pass in any dictionary I want written to that file. So I can do name, colon, name, and then for instance number, colon, number. And let me go ahead and reopen phonebook.csv, enter. Let me move it at right here. Let me delete all of that. And notice what happens this time, more like your real world of using Excel and Google Sheets and Apple numbers. Notice now when I run python of phonebook.py, enter, and I type in Yulia and +1 617 495 1000, enter. Notice that it too works as well. And if I wanted to as well using a dictionary writer, I could additionally tell this writer to include the names of these columns in that file so that when I open it up in Excel or Apple Numbers or Google Sheets, also the data is described in that first row of headers that you're probably familiar with from having just used spreadsheets in the real world. So long story short, this is not to ingrain in you exactly how you read and write CSVs or write in this case, but rather with just a few lines of code, like 6 lines of code, you can do a lot more in Python than you can in C. So now to end on a lighter note, let's do this. It turns out in Python, there's not only all of these libraries that come with the language, but there's also third-party ones that you can install as well. And there's a program you can run in a Linux environment, like your own code space, called pip, which allows you to install additional packages. That is to say, third-party libraries that other people have written. What this means is that in advance of your using cs50.dev, we essentially ran pip install cs50 to make sure that by default you just have access to cs50's own library. It does not come with Python, but it's out there in the cloud somewhere, and pip knows how to install it. But suppose I want to do something fun, like from a few weeks back where we did cow say, and we had a cow moo on the screen, and we had a dragon and other things too. Well, it turns out there's a package called cow say that I can install for Python with pip install cow say, enter. You'll see on the screen a bunch of stuff happening because it's downloading it and it's installing it into the appropriate location. But now this means there is a library called cow say in my own code space. So if I go ahead and create a program called like moo.py in this file, I can now import cow say, which will give me access to any functions and symbols therein. And I can do something like this per its documentation. Cow say library .cow, because this is going to print a cow on the screen, and I can say this is CS50. And down here, I can do Python of moo.py, enter. Oh, let's make the terminal window bigger. Let's do this again. Python of moo.py, enter. And I get a cow saying this is CS50 in a little speech bubble like that. I can make it more interesting now in code, though, as follows. If I shrink my terminal window and I use something like Python's input function, I can ask the user for their name, like what's your name, as we did way back with Scratch, and then C. And then I can use one of these F strings in here. And instead of saying this is CS50, I can say something like hello, comma, name in curly braces. Then down here, I'll make my terminal window bigger, run Python of moo.py, enter. What's my name? David, enter. And now the cow is mooing dynamically based on what I've just actually typed in. We can do things even fancier than this. Lastly, let me see if I can type this out correctly. In my terminal window, let me go ahead and install pip install QR code, these two-dimensional barcodes nowadays that are seemingly everywhere. This is going to install a library that's going to know how to automatically create a 2D barcode for me based on any text that I give it, including a URL, because someone else wrote the code that figured out how to do all of that and output a two-dimensional code. So let me go into a program called qr.py that I myself will write, but I'm going to stand on that person's shoulders, and I'm going to import a Python OS library, which gives me access to the file system so I can read and write files. And I'm going to import that person's library, QR code. I'm going to now create a variable called image, set it equal to qrcode.make, because I want to make a QR code. And I'm going to type in like the URL of one of CS50's lectures. So https://youtube/xvfzjo5pgg0. And hopefully, I made no typographical errors there. Then, on my next line, I'm going to call image, which is the name of that variable, .save. I'm going to save this as a file called qr.ping. Turns out this library supports different file formats, like ping, PNG for portable network graphics. So I'm going to say, give me that type of file. Then, I'm going to go ahead and run this program as follows. Python of qr.py, enter, no errors. I'm going to now open up qr.png, enter. Hide my terminal window, give you all a chance to open your phone and open the URL that's secretly embedded in this QR code. And at the risk of incurring your ire, there we go. This was CS50. We'll see you next time.